Now, learning something in general is one thing, but applying it with numbers, no doubt, it gives us perfection. Just like in our previous video, we learned how to represent a complex number in its equivalent polar form in general. We started by taking a complex number on an Argand diagram, identified its distance from the origin by joining it with a straight line and labeling it as r. It came out to be the modulus or the absolute of a complex number associated to that point. We also learned that there exists an angle theta known as the argument of a complex number. It is the angle that this point makes from the positive x-axis and can be calculated using the tan inverse function. Since we are done with all this in general terms, let's bring some quantitative values and practice to this concept. So, we have a complex number here, 1 plus iota root 3, where this is the real part of our complex number, and this part with iota is imaginary, of course. We need to express it in its equivalent polar form. Now, we know that real part is represented by x, while the imaginary part is represented by y, right? Hence, x is equal to 1 and y is equal to root 3. Now, according to the polar form, x is equal to r cos theta and y is equal to r sin theta. It means that to express the given complex number in polar form, we need the numerical values of r and theta, right? Let's get them. Step 1. By comparing these two, we can say that r cos theta will equal to 1. Similarly, r sin theta will equal to root 3. Now, in the second step, let's find the value of r. We know it is none other than the modulus of this complex number. So, by simply substituting the values, we get r equal to 2. And in the last step, we will find the value of angle theta using tan inverse function. Substitute the values of x and y again and simplify a little, and we get theta equals to 60 degrees. Lastly, substitute these values of r and theta here. And finally, we get the polar representation of the given complex number 1 plus iota root 3 as 2 cos 60 degrees plus iota 2 sin 60 degrees. Easy. Now you know how to convert a complex number to its polar form. But tell me friends, now when I say the polar form, do you think of this or this? Told you, the world of mathematics will change the world around you. Now, don't forget to practice some more questions until you become an expert at expressing a rectangular form of complex number into its polar form. Why? Well, some high-level questions await you in our next lesson. See you in our next video.